Now, 10.2 is very much interesting. I have to calculate the maximum area for the rectangle EFGH, of which at this point, I already have the expression for that rectangle. Let me tell you something. Whenever you hear the word maximum, and you have to determine the maximum area of something, not just in this situation, you must know that you have to differentiate, solve for x, and then take the maximum value, and then you substitute it to the original given expression, just like when we are getting a turning point for a quadratic function, something like that, similar there. So now, this is how we're going to go. We already know that the expression of a of that area is a of x is equals to 6x squared minus 3x to the exponent 4, right? And then I will differentiate this and equate it to 0. So I'll have a prime x is equals to, if I differentiate this, it's going to be 12x, because it's 6 times 2 and then 2 minus 1. Therefore, for this one, it's going to be minus 12x to the exponent 3, because it's 4 times 3 as well as 4 minus 1, the exponents, and then we get this expression here. Therefore, 12x minus 12x cubed is equals to 0, and then I will solve for x here. Just to put this properly, I can write it like this, such that I wanna have my first factor as a positive. So I will have, if I multiply by negative throughout, I will have 12x to the exponent 3 minus 12x is equals to 0. Here I have a common factor of 12. If I take out, it's 12x actually. If I take out the common factor of 12x, I'm left with x squared minus 1 is equals to 0. And I can factorize this one further, such that I will have x squared, 12x squared is x minus 1, and x plus 1, because I have the difference of 2 squares there, such that the value of x for this one would be x is equals to 0, or for this one, x is equals to 1, and then for this one, I have x is equals to minus 1. But I want the maximum value for x. So for the maximum value, I'll take the maximum value right here, because 0, an area cannot be 0, obviously. But then between this and this one is the minimum, this one is the maximum. So I will take this one. So I will then go and say a to the x is equals to 6x squared minus 3x to the exponent 4. Therefore, what would be a of 1? A of 1 would be 1 squared minus 3. I put the 1 there to the exponent 4. If I simplify this, I will have 1 squared is just going to be 1. So I will have 6 minus 1 to the exponent 4 is also going to be 1. So it's going to be 6 minus 3, which makes the maximum area to be 3. That's what you get. So the maximum area that was required, the maximum area for rectangle EFG is 3.